This is another problem. Let us see in power energy. At the county fair, Katie tries her hand at the ring the bell attraction, as shown in figure. She swings the mallet hard enough to give the ball an initial upward speed of 8 meters per second. Will the ball ring the bell 3 meters above the bottom? Okay. This is the problem based on the law of conservation of energy, where the total initial energy of the system is equal to the total final energy of the system. Here, the system is an isolated system, so the total energy of the system is conserved, or the total energy of the system remains constant. Okay. So EI is equal to EF. What is EI? EI is, well, let us write the mechanical energy is of two forms, kinetic energy and potential energy. So it has the Ki plus UGI must be equal to Kf plus UGF. Okay. Here, what is the data given to us? Initial velocity is given to us as 8 meters per second. And then initially the object is at the reference point. So h is equal to 0. This implies UGI is equal to 0. Okay. And then the final velocity is equal to 0 because at the maximum height, the final velocity is equal to 0. This implies Kf is equal to 0. Okay. And then we have to find out the final height. Okay. So here we are left with Ki is equal to UGF, because the other two terms UGI and then Kf becomes 0. Therefore, we are left with Ki is equal to UGF. What is Ki? Ki is equal to half mvi square, and then UGF is equal to mghf. Okay, hf we have to find out. Now mass goes off in the equation, and then hf is equal to vi square by 2g. Okay, and then g value is equal to 9.8 meters per second square. Therefore, hf is equal to 8 square divided by 2 into 9.8. Therefore, hf is equal to, what is the value? 64 divided by 19.6 gives 3.26 meters. And then he is saying that the bell is at the height of 3 meters. So easily she can ring the bell. Okay, the ball will ring the bell. That's the answer for the question. Okay, thank you. Bye-bye.